Welcome back, chemistry fans. Today, what we are going to try and learn about is something called the electron configuration. Let's go ahead and jump in here, Unit 1, Topic 5. So here we go. On this, what you need to understand primarily is that the electron configuration is simply an address for where electrons are most likely to be found. Well, one of the previous things that we had talked about is some of the information about where these energy levels are on the periodic table, and that's going to give us some hints about where the electrons are found. So let's take a visit back to an old topic where we talked about energy levels. Energy levels on the periodic table are reflecting on the periods. So if we have 7 periods, we have 7 possible energy levels. These energy levels can be then thought of as the rings that are going around the periodic table. Around the nucleus of the atom. So if you have 1 energy level, you only have 1 ring. If you have 3 energy levels, you have 3 concentric circles going around the nucleus, ever increasing distances as we go. All right. So once we reestablish that piece of knowledge from our periodic table, we then need to revisit the idea of the electron, now we need to be introduced to the idea of an electron configuration. If we think about our address, there are 4 parts of our address. There is the house number, there is the street, there is the city, there's 5 parts. There is the city, there is the state, and there is the zip code. All 5 of those parts come together to tell you the exact location of electrons. Well, if I were to then want to figure out what the electron configuration is, the address of an electron, I would need to know that there are 3 parts, 4 that we need to know about, but 3 that you will be responsible for as far as assessments are concerned. And they have its own language, kind of like a zip code has its own language that means something. You have to understand the system before you can tell me where someone lives. We have to understand the system before you can tell me where the electrons exist. It's going to be this series of numbers, letters, and exponents are going to be how we are going to tell where the electrons are located. Now, the nice thing is, after we're all done with it, we're going to have a short method to help you through it, a shortcut method, and it deals with this triangle that is over on the left side, this pyramid, if you will, however you want to phrase what that is coming to. Now, the electron configuration is quite similar. It pairs up nicely with the Bohr model. The Bohr model is a representation of where electrons can be found spatially around that nucleus. And what you will notice is those energy levels are reflective of the periodic table's representation of the number of energy levels or the number of electrons that are in them. So I'm going to look at neon on a periodic table, and you're going to come back to this image of the Bohr model, and let's see if we can maybe pair the 2 of them together and make heads or tails of it. So if we were to look at our periodic table, what we will remember about it is that the number of protons represents also the number of electrons. So for neon over here, it's element number 10. Now, what I want you to also notice is it's sitting on the 2nd energy level. So what that means is it has 2 circles around it where electrons can be found. And if we take note how many are on the 1st energy level, there appear to be 2 electrons that would be representative of the 1st energy level. And then if we counted similarly the number of elements, the number of electrons that are possible for the 2nd, we've got 8 out here. We could represent those with little dots as well. And so our Bohr model for neon ends up being exactly what we created here as our document, or as our example showed there, where we have neon having 2 on the 1st ring and 8 on the 2nd ring. Now, if we then want to relate this to this new concept of the electron configuration, the language tells us, instead of showing you where the electrons are found, in the 1st energy level, the big number at the beginning, there are 2 electrons. So we translate that information. The S is a further indication of where they are located. And then if we look at the second piece here, well, I have 2 of them in the S sublevel, and I have 6 of them in the P sublevel. And you're saying to yourself, hopefully, well, what does S and P mean? Well, they're just part of a language that the scientists originally came up with that made sense to them. It reflected how they viewed these electrons whenever they were observing the atom. Now, what it means to you, though, how you can decipher it is I need you to make note on this second energy level. There are 2 electrons on the left side, which we're going to call S. There are 6 electrons over on this right side that are called the P's. So if I'm on the second energy level, I have 2s2 and I have 2p6. If I were down on the 4th energy level, they'd be 4s2 and they would be 4p6. Okay. So now we're ready to move forward with our understanding a little bit more firm with what the electron configuration is. So let's now break it down. The first value is the energy level. It is a 1 that is capitalized. It's bigger than the lowercase letter. And the letters that you will have choices to select from are S, P, D, and F. And we will cover where they are on the periodic table, just like we did for the S and the P. And then the number of electrons is reflected as this exponent. You're saying, why did they make it an exponent? Because it would get confusing if I had 1s1, 2s2. You wouldn't know if that is supposed to be a 12 or if that's supposed to be a 1 and a 2 side by side. So they chose to make them exponents to try and distinguish it a little bit from one another. All right. So I'm going to now get us to a pizza analogy. Hopefully you'll try to bear with me as I try to show you what those pieces of the electron configuration, how they are representative on this model. Electrons all can fit into an energy level. The energy levels are representative of the periods that are on the periodic table 1 through 7. So somewhere inside that ring is some electrons that are confined to it. Well, as we get bigger, we will want to identify more specifically where they are located. And that's where we break this into sublevels. Well, keeping in mind, or try to keep in mind, that you can take a pizza and you can divide it into portions. So sublevels are organized into one of 4 different possibilities: S, P, D, or F. So there are 4 possibilities for which we can identify the location of electrons. The orbitals are going to be the serving sizes that we have the option. So a serving size of pizza is, generally speaking, 2 pieces of pizza. It just so happens that these orbitals tend to take the shapes that you are seeing here, something kind of like a teardrop shape that points towards the center of the atom, where the nucleus is. Now, the directions of the orbitals are either X direction, Y direction, or Z direction. So we can have these orbitals in different directions, depending on how many we have. The electrons tend to go in either one of 2 different directions. They are either going in a positive direction, or clockwise, or counterclockwise. And so what they do is they give them the spin designation of either positive or negative. So these are the 4 parts of that electron configuration. But the good news is you're only going to be responsible for the top 2, telling me how many electron energy levels and what sublevel it is. And then we just determine how many electrons are in that area. So as a refresher, energy levels go along with the periods on the periodic table. What you don't need to know about, but it would be a nice to know, is that these orbitals combine together to make sublevels, and we give them designations S, P, D, and F, and they look like these teardrop shapes. somewhere in this structure are where the electrons are located. So if we were to have in the 1s sublevel, we would have 2 electrons. And then the 2s, we would have 2 more electrons. And then in the 2p, we would have 1, 2, 3, 4, 5, 6 electrons. If I combine that together, I've got 1s2, 2s2, and 2p6. So I'm trying to build up your knowledge of how the electron configuration all works together with what we know these atoms look like on the inside. So now here's where I reveal where the other letters. I have shown you where the S's are located, the P's are located, keeping in mind that helium is also an S. It's in the wrong side, but that's just the way it's positioned on the periodic table because it's a noble gas as well. The D's happen to be the middle, and the F's happen to be the actinide and lanthanide series down at the very bottom. Now, one of the things you will notice that is key to understanding fully the electron configuration is that you start with the 4s and then you work backwards to fill up the 3 Ds. And the reason for this is something called the octet rule. The octet rule says that you can have a maximum of 8 electrons on the outside ring. If you have more than that, you must start filling up the inside. And that's the reason why these Ds are always going to lag 1 behind. In fact, the Fs are going to lag 2 energy levels behind. So we will end up, the maximum electrons in the S's are 2, the maximum in the P's are 6, the maximum in the D's are 10, the maximum in the F's are 14. If we talk about energy level in their maximums, we would have 2 for the first energy level, 8 for the second, we would have 18 for the third, and 32 for all the other electrons in their energy levels 4, 5, 6, and 7. And that is what is reflected here, the maximum number of electrons that can fit into those energy levels. All right, we are ready to start trying to practice this stuff here. So let's see what we can do now. Here we have lithium through neon. These are elements 3 through 10. The only ones that are missing for whatever reason on this example are hydrogen and helium. So I can write that out. Hydrogen is element number 1. Well, let me write it. Hydrogen, it's element number 1. It's H is its symbol, and it's 1s1. Helium, element number 2, its symbol He, and it is 1s2. Well, we know that the maximum that can fit in the first energy level is 2, and that's told to us on the periodic table. There are only 2 elements on the first energy level. So what happens? You go to the second energy level and you start filling it. And here's where you have 2 S2s, and then you come across and you establish then the 2 Ps. Well, once we filled that, we've hit our octet rule. We'll go to the third energy level where we can fill 3 S2 and 3 P6. We filled with our octet level. Now we go to the 4s2. But remember, we can only have a maximum of 8. There are 10 electrons here. That would violate the octet rule. So instead, they go back to the third energy level and they start filling in. So this now helps us to understand why there is a maximum of 18 on the third energy level, because we gain these additional 10. And then it goes back to the 4p, and then it starts with the 5s again. So everything is starting all over. So as you notice, the P is ever increasing in the section on the right side. The S's are ever increasing on the left side. All right, so now we are ready to understand something else. The electron configuration starts getting long, laborious, confusing. And so what we can do is we can truncate it. We can short it. We can make a abbreviation. The abbreviations are only allowed for the elements that are noble gases. So in other words, if I don't want to write all of the information for carbon, Carbon is 1s2, 2s2, 2p2. If I don't want to write all that, I can abbreviate the previous completed energy level. The previous completed energy level would be helium. If I wanted to do silicon, silicon is 1s2, 2s2, 2p6, 3s2, 3p2. If I can see that neon is the last completed energy level, I can get rid of all of the first and second energy levels, and I can just write neon inside of brackets. So you can always write an abbreviation as long as it is for a noble gas of the previously completed energy level. So here it is for lead. Lead is element number 82. If I were to add up all of these electrons, every single one of those added together, I would equal up to be 82. Or what I could do is notice that lead is on the sixth energy level. So if I notice that lead is down here on the 6th energy level, that means that I could use the previously filled energy level xenon as a shortcut. So that's what I did. This represents 54 of the electrons. I add in the remaining electrons that are on the same, that are on the next row, the 6th energy level. So I finish the 5th, I add on whatever's left over in the 6th. All right, so let's do a little practice here. Hydrogen, element number 1. It's 1s1. Helium, element number 2 is 1s2. Sodium is element number 11. So let's now go and look at a periodic table and see if we're out what we're going to do with sodium. Let me flash forward. Sorry, I scrolled to the wrong thing. Sodium. Sodium is element number 11. So therefore, it's on the 3rd energy level. So let's use that and fix it here. Let's fix it here. 11. So that's 1s1, 1s2, 2s2, 2p6, 3s1. So let's go see how that came about. Here are 1, 2 on the 1st energy level. Here is 1, 2 in the S's. Here are 1, 2, 3, 4, 5, 6 in the 2nd. And then finally we have 3 and it's in the S. So that's 3s1. Next example we have is for gold. Gold is a booger. It is huge. It has got a lot of them, and you would probably get lost on the way. So let's learn a new method, and then we're going to come back to it. So let's come over here to gold. And then we're done for the day. I'm going to go back to that pyramid, and the pyramid is something that you will need to be able to construct, to be able to coordinate with. If you take the time to memorize it, I will show you how to go about it. So I'm going to, you know what, let me go onto a new screen and we'll go from there. So on this, I'm going to construct that pyramid. So I know that there are 1, 2, 3, 4, 5, 6, 7 energy levels. I know that there is an S, a P, a D, and an F for each one of these energy levels. So I've got a S for each one of these. Now the P's don't start until the 2nd energy level. So I will put in a 3P, a 4P, a 5P, a 6P, and a 7P. The D's don't start until the 3rd energy level, 3D, 4D, 5D, 6D, 7D, and the F's are going to do the same. They're not going to start until the 4th energy level. So we always sync back one more from them. All right, now gold is element number 79. I know the maximum number of electrons in the S's are 2s. The maximum on the P's are 6. The maximum on the Ds are 10. The maximum on the Fs are 14. So what I'm going to do now is I'm going to then start writing my electron configuration based on this. I got 1s2. I go diagonally, 2s2. I go diagonally next, 2p6, 3s2. I go diagonally through the next line, 3p6, 4s2. I go diagonally through the next, 3d10, 4p6, 5s2. Let me see where I'm heading to. I go to the next one. I got 4d10, 5p6, 6s2. I'm still not there. I'm going to get there on this one here. 4f14, 5d9. All of this is my sum. If I add up all those values, it's going to be 79. Now, to truncate this, gold is on the periodic table on the 6th energy level. It means I can write xenon as my shortened form and then add in all of the last remaining parts of this. So what I can put is xenon, and that one ends at 5p6. So all of this gets cut off, and then I would just add in my 6s2, 4f14, 5d9. That sums everything up. I hope that you can practice this and get better at this. This is just a starting point. Thank you so much. Goodbye.